Hi everyone, now we're going to begin the review for test 4. So here's the first question. What is the frequency of a 6.24 millimeter long pendulum? So go ahead and pause, try to solve this, and when you're ready, unpause. Alright, so let's write down what we are given. So there's only one number, 6.24 milli is 10 to the minus 3 meters, so this is some kind of distance. So let's draw a picture. So there's a pendulum. You have a support. So the pendulum has a length L, and it's going to vibrate back and forth. And we're trying to find the frequency at which it vibrates. So the 6.24, that's the length of the pendulum, and we want to get the frequency. So here, the pendulum has the equation, so we're going to have to use two equations. Frequency is defined as 1 over the period, but the period of the pendulum is defined as 2 pi multiplied by the square root of the length of the pendulum divided by g. So let's get the period first. So the period is going to be 2 pi multiplied by the square root of the length, which is 6.24 times 10 to the minus 3, and divided by 9.81. And so that's going to give you a period of 0.158 seconds. So it cycles once in 0.158 seconds. So now we want to get the frequency. The frequency is going to be 1 over the period, which 0.158, which is going to be 1 over the period, which is going to be 1 over 0.158. And that will give you 6.3 hertz. Alright, so let's try this word problem. It says a speaker vibrates at a frequency of 277.8 hertz and sends out a sound wave through the air while the air is held at negative 10 degrees Celsius. Find the velocity of the sound through the air, and also find the velocity of the wave through the air, and also the wavelength. So go ahead and pause, try to solve this, and when you're ready, unpause. So the numbers that we have are 277.8 hertz. So hertz is our frequency. And negative 10 degrees Celsius, so that's the temperature. And A, we want to find the velocity, and B, we want to find the wavelength. So what's happening is that you have a speaker, it's vibrating, it's sending out sound waves, and the sound waves are passing through the air while the air is held at, so the air molecules are held at a temperature of negative 10 degrees. So we can use that to figure out how fast the sound is going to move, so V sound. And once you have that, now we can calculate the wavelength of the wave, because we know that the speaker is going to vibrate up and or back and forth with the frequency F, and we can use that to get the wavelength lambda. So first, let's get the velocity of sound. So velocity of sound is defined as 331 plus 0.6 multiplied by the temperature in Celsius. So that's going to be 331 plus 0.6 times a negative 10. So the velocity of sound is going to be 325 meters per second. Next, now we can get the wavelength. So there, the velocity of the wave is equal to the frequency of the wave multiplied by its wavelength. And we can use that to get the wavelength. So plugging in, velocity is 325, frequency is 277.8 hertz times the wavelength. So the wavelength is going to be 325 over 277.8, which will be about 1.17 meters.